In this lesson, we're going to look at electrolysis and half equations. As an example, we're going to take the electrolysis of fused sodium chloride. Now, here we have the atoms of sodium and chlorine. Okay, remember that sodium has got 1 electron in its outer shell and chlorine has got 7. Sodium and chlorine. Now, when the two atoms come together to form a compound, the sodium loses its electron like that, and in doing so it becomes a sodium ion acquiring a positive charge, and it donates its electron to the chlorine, so the chlorine becomes a negative ion, and that has a charge of -1. Okay? And they'll come together to form a lattice like this, and you can see the sodium, the smaller ion, has the positive charge, and the chlorine, which is the larger ion, has the negative charge. Now, if I try to pass a current through solid sodium chloride, even though there are negative and positive ions present, a current cannot flow because the ions are held in a fixed position. So one of the ways in which we can get sodium chloride to conduct electricity is to heat it and melt it so that the positive and negative ions become free to move. Let's do that. Okay, to melt sodium chloride you need to heat it to around about 800 degrees Celsius. Okay, and once you do that, the ions break away from the ion lattice and then they're free to move. So what we've got here is the electrolysis of fused sodium chloride. Now, fused is another word for saying liquid, or that it's in the liquid state. Let's introduce those ions. Let's just talk about this arrangement for a minute. We can see we've got 2 electrodes, and the electrodes are connected to a battery. That's the positive terminal of the battery. That's the negative terminal of the battery. So this becomes the positive electrode. That's also known as the anode. And this becomes the negative electrode, which is known as the cathode. Now, just to confuse you, the positive ions, that's the sodium ions, the positive ions are called cations, and the negative ions are called anions. As soon as the switch is thrown, an electric current starts to flow, and what will happen is the negative anions, in this case the chlorine ions, will start to move towards the positive electrode. All right? Like that. And when they arrive at the positive electrode, they will give their extra electron to the electric circuit, and electrons will start to flow around the circuit as more and more chlorine ions donate their electrons at the anode. Okay, so there they go around the circuit. So we have an electric current flowing this way. Now, at the same time as the anions are giving their electrons to the anode, the cations, that's to say the positive sodium ions, are moving towards the cathode. And when they arrive at the cathode, they will collect the electrons that are flowing around the circuit. So what we can do is we can write an equation for the changes that are taking place at each of these electrodes. Now, these equations are called half equations. So first of all, at the anode, we have the chlorine ion with a negative charge. It gives up its electron and becomes a chlorine atom again, and donates its electron to the electric circuit. Now, you remember that chlorine gas, as it exists in the atmosphere, doesn't exist as an atom on its own. It forms a covalent bond joining together with another chlorine atom to form a diatomic molecule. So we really should write a 2 here. So what's going to happen at this anode is that chlorine gas, that's Cl2, is going to be released at the anode. Okay. So before we go any further, we need to balance this half equation. You see, we have 2 chlorine atoms here, but only 1 here. So we need to put a 2 here, but that means we've got 2 negative charges here, so we also need to put a 2 here, right? And now the half equation is balanced. Now at the same time as the chlorine ion is donating an electron at the anode to form chlorine gas, well, the sodium ions are collecting electrons at the cathode to form sodium. All right, so we have sodium and picks up an electron and forms sodium. And as a result of that, we're going to have a layer of sodium deposited around the cathode. Now, when we're writing half equations like this, what is very important is to make sure that the number of electrons are the same in each case. In this half equation, 2 electrons are donated to the anode, then 2 electrons must be picked up by the cathode here. So we're going to have to put a 2 here, right? So that we've got 2 electrons being donated and 2 electrons being picked up. And if we put a 2 here, then we've also got to put a 2 here and a 2 here, so that that equation is balanced. Okay, so these are called the half equations for the electrolysis of sodium chloride.